Okay, we will continue. This is now classification accuracy assessment. This is very important, a very important topic for digital image processing and analysis. You know, most students usually when they finish their image classification, they consider that's the end of it. But there is another very important task after image classification, which is reporting classification accuracy. This is a very important topic. So unless you report your accuracy assessment result, your classification result cannot be trusted. So you have to know what are the methods of reporting classification accuracy. What are the matrices and what are the procedure to be followed in order to assess the accuracy of my classification result. So these are some of the most important points to be pointed out. And what are the steps in error assessment? First, you have to determine the total number of samples to be collected for each category. Category means the classes. For example, if you have 3 classes, forest, grassland, and water body, I have 3 categories. So I need to collect sufficient number of samples for each categories. For forest category, I have to collect sufficient number of samples. For grassland, for water body, we have to collect sufficient number of samples. And the second step is you have to design an appropriate sampling scheme. There are 2 methods of sampling. These are traditional sampling scheme and geostatistical sampling scheme. So if you like, you can choose traditional or geostatistical. Geostatistical sampling technique is a bit advanced and it is beyond the scope of this course. So you can follow traditional sampling scheme. Obtain ground reference information at sample locations. Okay, once you finish your classification result, suppose you have 3 categories, so you have to obtain ground reference information by going directly to the field using GPS. GPS means Global Positioning System at different sample locations. These sample locations can be assessed or can be selected randomly. Then finally you produce error matrix. Okay, error matrix can be produced once you finish this prior stage, and then you evaluate the error matrix. So how can you determine the sample size? The sample size can be determined by some kind of rule of thumb. For example, a minimum of 50 sample for each land cover class is expected. For example, if I have 3 categories, 3 times 50 becomes 150 samples are expected of me to collect for accuracy assessment. If I have 5 classes, 5 times 50 becomes 250 samples needs to be collected. With regard to the design, there are 3 different traditional sampling techniques: random sampling, systematic sampling, and stratified sampling. Most of the time we use stratified random sampling because land cover classes by themselves can act as a stratifying strategy. So we collect samples based on land cover category. So we follow this stratified random sampling technique. So now let's come to classification error matrix. The error matrix sometimes called confusion matrix. Confusion matrix because it is a result of spectral confusion. Spectral confusion. It is not the confusion of the analyst or the software, but it refers to the confusion of spectral wavelengths. So sometimes it's called contingency table. But error matrix can be defined as it is a matrix, or it's a table which compares the relation between known reference data or ground truth and the corresponding result from the classification. So this is a definition of error matrix. Error matrix is a table, it's a crosstab which compares result from ground truth and result from your classification. So accuracy is essentially a measure of how many ground truth pixels were classified correctly. Okay, is that 90%, is that 86%, or is that 90%, or more than that? So there are three types of accuracy matrices: producer accuracy, user accuracy, and overall accuracy. And producer accuracy is usually calculated by comparing the correctly classified pixel of a class over the total, the column total, while user accuracy can be calculated by dividing the correctly classified pixel of a class over the row total. This is user's accuracy. So users usually compares the correctly classified pixels with the total number of pixels from the classification results, while producers compare the correctly classified pixels with the total number of pixels that you collected or that you counted from ground truth. So the comparison between the diagonal element versus ground truth is for producer accuracy. The comparison between the classification and the diagonal element gives you user accuracy, while the overall accuracy tells you the total number of correctly classified pixels over the total number of pixels in an image. Okay, usually the diagonal elements are the correctly classified pixels. So I have an example. This is an error matrix. As I told you earlier, an error matrix is a table which compares validation result or validation data with classified map. We do have now three classes: forest, water body, urban, in the classification as well as in the field data. As you can see, the diagonal elements are the correctly classified pixels for each category. So when you calculate overall accuracy, you sum up the correctly classified pixels for each class, 28 plus 15 plus 20, over the total number of pixels, that is 100, becomes 63% is overall accuracy. While when you are requested to calculate producer's accuracy, as I told you earlier, it compares the correctly classified pixel of that specific class with the validation data column total. So producer accuracy for forest becomes 28 over 30. Producer accuracy for water becomes 15 over 30. And producer accuracy for urban becomes 20 over 40. While user accuracy for each class can be calculated by comparing the correctly classified pixel of that class over the classified result of row total. So 28 over 57, 15 over 21, 20 over 22. So you have 1, 2, 3, 1, 2, 3, 6, plus 1, 7. So in computing or in assessing the accuracy of a classification result, you are requested to compute 7 classification error matrices. Okay? So you can also do this exercise. What is the overall accuracy for this classification? If you have 1, 2, 3, 7 classes result from validation and from classified data, you can do this exercise if you like. But this is a very important exercise which will make you you know, a very good, which will give you a very good understanding about classification accuracy assessment and image classification. For example, take this exercise, exercise 1 and exercise 2. Try to compute and do these two exercises. I will give you 5 minutes for this and 5 minutes for this. So I'll get back to you again. And now let's come to change detection. Change detection, as the name indicates, change detection. Okay, identification of changes in land cover. So land cover is a very important task if you are using the land cover, the classification result for change detection. Okay, so what is the purpose of change detection? One is to map patterns of wetland loss, forest change, urban expansion, agricultural expansion, irrigation expansion can be obtained from change analysis. Okay, change analysis can be obtained from two-time period analysis. Okay, a one-time image classification cannot give you or cannot give you anything about change. The second reason is to analyze the rate of such change. Is urbanization rapid or slow? Is wetland loss rapid or slow? Is the forest change rapid or slow? So the rate of change can also be calculated through change analysis. Change can be monitored. So these are the two issues. These are some of the examples of wetland change or wetland loss and forest loss. Okay, you can develop this type of map in order to see whether our environment is degrading or improving. There are a couple of steps that you need to follow in digital change detection analysis. The first thing that you need to do is you have to be able to state the change detection problem. What's the problem of the change? Do you want to explain how urbanization is expanding, or do you want to explain forest loss or something like that? So you have to state that change detection problem. Okay, in defining its state, you are required to define the study area, the frequency of change detection. Do you want to do it the change detection annually, or in 10 years time, or in 30 years time, or is a change seasonal? These are some of the questions that you need to ask. And identify classes from appropriate land cover classification systems. These are under this that needs to be explained. And the second one is considering significant factors when performing change detection. Okay, consider the temporal resolution. Is the temporal resolution a weekly time? It's a 16-day time, or 32 days, or monthly, or annual, or something. And also you need to pay attention to the spatial resolution, the spectral resolution, and the radiometric resolution, and other atmospheric conditions. Do I want to make my change analysis at the time of the year where soil moisture condition is almost zero, or did I consider phenological cycle when I select my image? Something like that. So then the third step is conduct image processing remote sensor data. So pre-process the multiple data remotely sensor data. For example, if you have if you want to make change detection since the fall of DERG, for example in 1991, you need to collect more than one time image. So those multiple date remotely censored data need to be pre-processed So the second one is select appropriate change detection algorithm, and you do the JS analysis. So before you implement change detection analysis, the following condition must be satisfied: precise registration of multi-temporal images. Okay, if you have 1986 satellite image and 2020 satellite image, you need to register two of the images. Okay, so precise atmospheric and radiometric correction are required, and two of the images needs to be in the same phenological states, whether it is in dry season or in wet season. Okay, if you choose the wet season or dry season, most of the time we use dry season image of 1986, for example, and dry season image of 2020. Okay, selection of the same spatial resolution, spectral resolution of image, if possible, is required. Okay, if you have a 30 meter spatial resolution of 1986 image, you have to also select the 2020 image of 30 meter by 30 meter spatial resolution. So these are some of the things that you need to consider. Okay, there are a couple of methods for change detection. Most of the time we use post-classification comparison. So once you finish your classification, then you compare the classified result. So you make a subtraction of one image over the other. So this is the post-classification comparison method. So this is a flowchart of the change detection. And there are questions that you need to answer. Okay, right, the 2 points. One has to understand electromagnetic radiation and its interaction with Earth's object. What is atmospheric window? What is the difference between passive and active? Why do we need radiometric correction? And what is the difference between supervised and unsupervised? What are the 4 categories of digital image processing? And I need to add one question. That is question 7 is so discuss or write the different ways in which image classification can be categorized. Okay, so these are the questions that you need to submit once you answer those questions. So that's it for today. Thank you very much for listening to me attentively.